and install a bathtub. Let us collect the tools, equipment and machinery required to do this. Ball peen hammer 1, drilling machine 1, chisel 1, pipe wrench 1, screwdriver 1, double-ended spanner 1, hammer 1, hacksaw 1, trowel 1, poker 1, spirit level 1, water tube level 1, measuring tape 1, screwdriver 1, silicone gun and sealant 1, power drill and drill bits 1 set, plumb bob 1, water pump plier 1, spade 1, straight edge 1, motor pan 1, pipe vise 1, GI pipe and fitting as required, thread seal materials as required, plaster of Paris as required, white cement as required, solvent cement as required, angle caulk as required, push caulk as required, sink with accessories as required, bathtub with accessories as required, cement as required, fine sand as required, bricks as required, SW pipe or PVC pipe with fittings as required, water as required, and valve as required. Let us start with the installation of a kitchen sink. Hold the sink in position. The height of the front edge of the sink from the floor level should be 80 centimeters. Mark the position of the mounting wall bracket. Make a chasing using a chisel. Install a wall bracket to the wall as per the structural rough-in dimensions and ensure that the bracket is level. Fix the CI cantilever bracket in the chasing using cement-concrete ratio of 1:2:4. Cure the concrete. Check the sink for any visible defects. Lay the sink on its back to assemble the drain for the kitchen sink. Assemble the remaining components as shown and thread the 4 screws through the drain adapter and into the sink inserts. Ensure that the screws compress the drain adapter evenly onto the sink. Install the faucets, valves, and optional soap according to the user manual or manufacturer's instructions. The next step is to mount the sink onto the bracket and wall. Ensure that the bowl is completely seated on the wall bracket and securely fastened to the wall at point A. Position the bowl above the wall bracket and press the back of the sink firmly to set the bowl flange into the wall bracket lip, making sure that the bowl is level. Secure the sink to the wall anchors using fasteners as per the structural rough-in requirement as stated by the installer. Next, we will install the strainer and P-trap. Connect chromium plated full threaded waste coupling to the sink. Provide the drain connection using GI or PVC pipe to the union and leave to the trap flow. Fix the sink tap. Provide water supply connection to the kitchen sink tap. Finally, test the sink for proper functioning and check for leaks and blocks. Next, we will learn to install a bathtub. Check the bathtub for any visible defects. Place the bathtub at the specified location while keeping the top level over a sand bed and cushion. Remove the two tubular cradle legs from the bath frame and retain the screws for later. If required, using the 23 mm fixing screws, attach the black housing socket to the bath frame. Align the cradle and handsaw directly into the baseboard using the 32 mm or 1 1/4 inch screws from before. Check the length of the screw. Should the bath have an edge frame fitted to the baseboard, align and secure the cradle to it. If the cradle stands proud of the baseboard, it can be shortened using a hacksaw. Once the cradles have been secured to the baseboard of the bathtub, secure them into the leg toggles with the self-tapping screw that have been provided, making sure that the self-tapping screw pierces the steel leg. This will be easier if pre-drilled with a 3.2 mm bit. Secure the adjustable M10 feet to the cradles using M10 nuts provided. Secure the adjustable center support using screw and nuts provided to the center of the baseboard or edge frame. With the bath in the upright position, set the top face level using threaded adjustment of the feet and lock nuts. When a panel is to be fitted, set the bath height to the height of the panel. Ensure that the bathroom is level using a spirit level. Connect the waste pipe to the waste hole. Assemble pop-up waste coupling. Fix waste coupling in the provided area. Connect the waste pipe into the pop-up coupling and connect the waste pipe into the drain line. Fix the mixture tap to the top level of the bathtub and connect the hot and cold water supply line. Fix the trap in the outlet. Connect the hot water line on the left side of the mixture unit. There should be handles on the top of the tubs. Fix the chain with rubber for maintaining the water level. Check the bathtub for proper installation and functioning after opening the taps. In this video, we have discussed how to install a kitchen sink and install a bathtub. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we are going to learn about installing an open type and concealed flushing cistern. By the end of this video, you will be able to install an open type flushing cistern and install a concealed flushing cistern. Let us collect the tools, equipment and machinery required to do this. Pipe wrench 1, measuring tape 1, spirit level 1, water pump plier 1, wide mouth channel lock 1, screw spanner 1, hammer 1, chisel cold flat 1, mortar pan 1, trowel 1, hammer drilling machine 1, Wall chasing machine 1, concealed flushing cistern as required, open type flushing cistern as required, thread seal materials as required, cement as required, fine sand as required, cotton waste as required, hacksaw blade as required, white cement as required. Let us look at installing an open type flushing cistern. Before installation, ensure to turn off the water supply. Position and fix the cistern support bracket in the center of the furniture carcass or in line with the desired location. When the bracket is firmly fixed, the cistern can be secured to the bracket. Hold the cistern in the center of the bracket and align the lugs with the recesses in the back of the cistern. Gradually lower the cistern to engage the lugs and push down firmly until the center clip snaps into place. Moderate lateral movement is available to assist the WC pan alignment. Complete the plumbing connections as required. Attach the flush valve gasket onto the bottom of the flush valve. Assemble the flush valve with the rubber gasket inside the tank, pulling the flush valve through the tank hole. Hold it in place and install the nut, tightening it by hand. With a pair of wide-mouth channel locks, grip the nut and turn it slowly to tighten the nut to the flush valve. Cover the flush valve nut with the tank-to-bowl gasket to seal off the joint between the tank and the bowl. Assemble the float valve inside the tank and pull the end through the float valve hole. Thread the nut on tightening it by hand. With a crescent wrench, slowly turn and tighten the nut around the float valve. Cut the cistern flush pipe to size and ensure that the large end of the pipe projects into the cistern valve. It is recommended to position the pan and check measurements before cutting. When satisfied with the fit of the cistern flush pipe, install the black inlet flush cone connector into the narrow end of the flush pipe. When satisfied with the position of the WC and the flush pipe, push the black WC inlet connector securely into the WC inlet. Test the flushing cistern. Let us secure the bowl to the flange or waistline. Place a wax ring on the flange. This will seal the bowl to the flange. Before placing the wax gasket on, make sure the bolts on the flange are in the narrow portion of the slots on the flange. Set the bowl on top of the flange. Note that not having the tank installed on the toilet bowl yet makes it easier to install the toilet bowl. Place the bolts through the toilet bowl fixture. Put the base for the cap first, then the washer and then the nut. Now, we need to install the tank to the toilet bowl. Before setting up the tank on the bowl, make sure that the gasket is on the exterior portion of the flush valve. Place the bolts attached to the tank through the housing that are on the bowl. Place the washer and the nut. Hand tighten the nut to the bolt. Do the same for the other bolt on the other side of the tank. Tighten the nut with a socket head wrench. Make sure that the tank is now secure. Attach the supply line to the float valve on the tank. Let us now install a concealed flushing cistern. Turn off the water supply. Draw a diagram by seeing the job sheet. The first step is to set up the frame. Assemble the vertical upright and horizontal support bars onto the frame and tighten them together. Slide the two fixing mounts onto the sides of the cistern, making sure they are fitted securely. Place the vertical flush pipe onto the underside of the cistern. Secure the cistern onto the frame. First, place the elbow of the flush pipe on the frame and then press down on the cistern to clip it into place. Use a 10 mm ratchet wrench to attach the fixing mounts on the frame. Insert and clip the feet onto the lower part of the frame. Install the clamp for the 90-degree waste pipe elbow onto the frame. Next, we need to position the unit and make markings. Using the spirit level, draw a vertical line that crosses the center of the waste pipe. Measuring from the floor for a standard bowl placement at 400 mm from the floor, draw a mark A at 1 meter and a mark B at 1.08 meters. If necessary, adjust measurements to match the requirements. On mark B, draw the holes for the wall brackets 235 mm to the left and to the right of the center of the evacuation. Complete the assembly by fitting the 90-degree waste pipe elbow into the clamp. Put the unit into place and check the position with respect to the water supply and waste pipe. Maneuver the 90-degree waste pipe elbow according to the installation either horizontally or vertically. If necessary, adapt the connection using the PVC piping. Make sure that the unit is at least 230 mm from the wall, then mark the locations of the holes for the unit and foot brackets. Let us now adjust and attach the unit. Grease the seal of the 110 mm waste pipe so that the 90-degree waste pipe elbow fits easily. If you are gluing the PVC connection, use a straight glue in 90/100 sleeve. For standard bowl placement, check that the height is 230 mm. Check to make sure that the unit aligns with the marks. If necessary, adjust measurements for the desired bowl height. Drill holes into the wall using a 10 mm drill bit. Insert the raw plugs. Drill holes into the floor using a 12 mm drill bit and insert the raw plugs. Adjust the frame height so that it lines up with the mark A. Secure the feet using a 13 mm wrench. Make sure that the frame is horizontally in level. Adjust the level by loosening the adjustment bolt on one of the feet using a 13 mm wrench, then tighten the screw. Make sure that the screw is firmly tightened on the other foot. Place the fixing brackets at the top of the frame. On the threaded rod, place one nut, two washers and one nut. Place the fixation brackets on the threaded rod with the clips open. Secure the brackets to the wall using a 13 mm open-end wrench. Adjust vertical alignment using the screws and spirit level. Use a 13 mm open-end wrench to tighten the screws. Close the metal clips to lock the screws. Finish by placing the plastic clips over the rod. Place the clip on the waste pipe clamp fitted earlier. Finally, let us install the flush mechanism. Pull the red handle to remove the transport bracket and discard it. Remove the cover to access cold water connection. Attach the exterior part of the stop valve to the cold water connection using a 22 mm open-end wrench and a pipe wrench. This assembly must be made without using a seal. Point the stop valve outflow to the right. Connect the internal flexible water inlet hose to the stop valve. Make sure that the isolation valve is closed and open the main water supply. Make sure that the isolation valve connection is watertight. Place the other end of the hose in a bucket to catch the water and then slightly open the faucet to check for water. Close the isolation valve. This operation flushes any debris out of the water connection to the cistern. Connect the end of the flexible water inlet hose to the flush system. Place the inspection shaft according to the orientation of your flush plate. Mark the position in the brick wall for concealing flushing cistern. Making holes with wall cutting machine, cold flat chisel and a ball peen hammer or hammer drilling machine. Connect the European water closed pan and fix the seat cover. Seal the gap around the bowl with waterproof cement or white cement. Check for the proper working of the concealed flushing cistern without any water leakage. In this video, we have discussed how to install an open type flushing cistern and how to install a concealed flushing cistern. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we are going to learn about the rainwater harvesting system, rainwater and drainage pipe system, and fixing the rainwater gutter outlet and ground pipe. By the end of this video, you will be able to make a pit and fill the pit with gravel, fix rainwater pipes, connect the pipes to the pit, cover the pit, fix the rainwater gutter on the metal shop end, connect the PVC pipe to the gutter, assemble the pipe shoe at the end of the pipe, Measure, mark and fix the pipe as per the drawing. Connect the pipe and fittings and check the joints. Let us collect the tools, equipment and machinery required to do this. Trowel 1, spade 1, pickaxe 1, mortar pan 1, hacksaw 1, hammer 1, straight edge 1, measuring tape 1, chisel 1, plumb bob 1, rowel jumper 1, caulking tool 1, spirit level 1, blow lamp 1, water tube level 1, screwdriver 1, bricks as required, sand as required, stone aggregate as required, cement as required, pipes as required, fittings as required, RCC cover or grating as required, drilling machine as required, mason pits as required, PVC pipe 6-inch as required, PVC pipe shoe as required, swan neck pipe as required, offset pipe as required, metal sheet as required, gutter as required, bracket as required, solvent cement as required, vent cowl as required, door cross Y etc. as required, thread seal materials as required, hemp yarn as required, lead as required, door bend as required, door tee as required, plain bend as required, plain tee as required, collar as required and a PVC bend as required. Let us look at the steps involved in rainwater harvesting. Determine the catchment area and clean that area. The place where rain falls directly is the catchment area. It collects water for the system. Choose a clean area on the property to collect rainwater. Determine the layout. The layout and location of the tank and pipelines are determined in such ways as to maximize the use of collection surfaces. There are several options, but the major ones are the spread out tank option and cluster tank option. Set up storage. The rainwater collected from the roof of a building is diverted to a storage tank. The storage tank has to be designed according to the water requirements, rainfall, and catchment availability. Each drain pipe and collecting system should include a mesh filter at the mouth and first flush, also known as roof washer device, which will divert the first flow of water away from the tank. A filtration system before connecting to the storage tank, an air gap to prevent stormwater backflow. Each tank should have an excess water overflow system, and excess water could be diverted to the recharge system. Installing the pipes and tanks. Seek necessary permissions if required from the authorities to lay the pipes. Dig trenches if laying it underground. It is preferable to have the pipe as a single fall to avoid sediment collecting in places that cannot be reached easily for self-cleaning. Lay the pipes in trenches or otherwise and connect using connectors. For installing tanks, make a tank stand as per the requirement. Place the tanks on a stand and ensure they don't blow away when empty. Connect them so they behave as one volume. It is recommended to put a valve for each tank for easy maintenance. Install first flush diverters to keep the most contaminated rainwater out of your rainwater tank. If the tanks are in a sump, it would require overflow arrangement drainages. When the overflow is undersized, the pumps will flood. Make the final connection between the PVC or suitable collector pipes and the tanks. Install a tank gauge to regularly monitor the water level and usage. Measure and mark the rainwater pipe. Measure and mark out the center line of the pipe using a chalk line and plumb bob. Check the pipe for bends or other defects. Fix the bracket. Take the measurements of the pipeline considering that the bend will be inserted in the pipe. The shoe will become 50 mm above the ground level. Make a hole in the parapet wall larger than the bend's outer diameter. Fix the bend. Join the pipes from the bottom of the bend. Fix the bracket loosely. Fix the shoe to the pipe and bracket. Test the pipe vertically using a plumb bob. Connect the rainwater pipe to the drainage pipeline. Test it for leakages. Fixing the drainage pipe system. Measure and mark out the center line of the pipe work installation on the wall. Mark the position of all fittings like the Y-bend. Check the pipe and fitting for visual defects. Measure the pipe work connecting the fitting including the length entering the socket. Fix brackets at standard intervals in the laying wall or structure. Keep the pipe and fittings in position temporarily with the aid of brackets fixed to the structure along the center line of the pipework. Ensure that each pipe is entered fully into the socket. Centralize the joint using small wedge or packing. Join the pipe and fittings using lead or cement mortar starting from the bottom. Tighten the bracket, cure the cement joint and check for leakage. Fix the rainwater gutter outlet and ground pipe. Place the gutter at the end of the rooftop or outer wall. Fix the gutter on the metal sheet end. Draw a pipe layout. Measure and mark out the center line of the rainwater pipe. To connect the rainwater pipe in a gutter outlet, join the pipe from the bottom of the gutter. Mark a hanger or bracket position and follow fixing of pipes. Fix the rainwater pipe with a bracket at the required length. Join the pipe and shoes from the bottom of the gutter. Connect the rainwater pipe shoes at the end of the ground level. Check the complete fitting on the joints. Ensure that the pipe is properly laid and hang pipes and fittings by clamping or screwing. In this video, we have discussed how to make a pit and fill the pit with gravel, fix rainwater pipes, connect the pipes to the pit, cover the pit, fix the rainwater gutter on the metal shop end, connect the PVC pipe to the gutter, assemble the pipe shoe at the end of the pipe, measure, mark and fix the pipe as per the drawing, connect the pipe and fittings and check the joints. Hope you have a clear understanding of this session. Thank you all and see you in the next video.
Importance of maintenance and cleanliness of workshop. Hello, my name is Charumati. I hope you are all excited for today's session. In this module, we are going to learn the importance of maintenance and cleanliness of the workshop. At the end of this exercise, you will be able to obey safety instructions and use personal protective equipment (PPE), maintain tools, instruments and equipment. Now let us take a look at the equipment Materials and tools required to do this exercise.
Tools or instruments required. Trainees Toolkit 1 set. Equipment required. List of workshop equipment. Waste bins. Materials needed. Lube oil. Detergents. Cotton waste. The first and foremost in workshop maintenance is to know the safety instructions that are to be followed and the importance of wearing necessary personal protective equipment. Task 1: Safety instructions and personal protective equipment. Some cleaning agents are toxic. Refer to the information about handling, use, and storage of chemicals that may be hazardous. Follow any recommendations made by the supplier before using it. Do not use flammable cleaners or water on electrical equipment. Make sure designated walkways are kept clear of any obstructions. Always wear protective clothing and the appropriate safety equipment. Make sure that you understand and observe all legislative and personal safety procedures you are carrying out the following tasks. If you are unsure of what these procedures are, ask your instructor. Task 2: Maintenance of tools and equipment. Clean tools and equipment work more efficiently. At the end of each working day, clean the tools and equipment you used and check them for any damage. If you note any damage, tag the tool as faulty. Electrical current can travel over oily or greasy surfaces. Keep electrical power tools free from dust and dirt and make sure they are free of oil and grease. All workshop equipment should have a maintenance schedule. Always complete the tasks described on the schedule at the required time. This will help to keep the equipment in safe working order. Store commonly used tools in an easy-to-reach location. If a tool or piece of equipment is too difficult to be returned, it could be left on a workbench or on the floor where it will become a safety hazard. Keep your work area tidy. This will help you work more efficiently and safely. Have a waste bin close to your work area and place any waste in it as soon as possible. Dispose of liquid and solid waste, such as oils, coolant, and worn components, correctly. Do not pour solvents or other chemicals into the sewage system. This is both environmentally damaging and illegal. Always use chemical gloves when using any cleaning material because excessive exposure to cleaning materials can damage the skin. Some solvents are flammable. Never use cleaning materials near an open flame or cigarette. The fumes from cleaning chemicals can be toxic, so wear an appropriate respirator and eye protection wherever you are using these products. Now that you have understood the basic maintenance of tools, let us learn how to clean them. Task 3: Cleaning hand tools, jack, power tool, and machinery. Clean hand tools. Keep your hand tools in good, clean condition with 2 sets of cabinets. One cabinet should be lint-free to handle precision instruments or components. The other should be oily to prevent rust and corrosion. Clean floor jacks. Wipe off any oil or grease on the floor jack and check for fluid leaks. If you find any, top up the hydraulic fluid. Occasionally, apply a few drops of lubricating oil to the wheels and a few drops to the posts of the safety stands. Clean electrical power tools. Keep power tools clean by brushing off any dust and wiping off excess oil or grease with a clean rag. Inspect any electrical cables for dirt, oil or grease, and any chafing or exposed wires. With drills, inspect the chuck and lubricate it occasionally with machine oil. Clean air power tools. Apply a few drops of oil into the inlet of your air tools every day. Although these tools have no motor, they do need regular lubrication of the internal parts to prevent wear. Clean hoists and heavy machinery. Locate and checklist or maintenance record for each hoist or other major piece of equipment before carrying out cleaning activities. Note: clean operating mechanisms and attachments of excess oil or grease.
We have come to the end of the exercise. Let us have a recap on what we have learned in this module. We have learned to obey safety instructions and use personal protective equipment (PPE), maintain tools, instruments and equipment. Thus, we have learned the importance of maintenance and cleanliness of the workshop. Do this exercise with the help of your instructor. Thank you. Carry out measuring practice on cam height, camshaft journal dia, crankshaft journal dia, valve stem dia, piston diameter and piston pin dia with outside micrometers. Hi, my name is Charumati and I will be guiding you throughout this exercise. Usually, when we measure any object, say for example, you are going to measure the length of an iron bar. Which measuring instrument would you prefer to use for measuring? If the object is small, for example, approximately less than a foot, then we choose a steel rule to measure it. If suppose the length of the object is more, then we prefer a steel tape. Do you know what is the smallest value we can measure with the steel rule? The steel rule which we use in the industries has 0.5 mm accuracy. It means we can measure a value as small as 0.5 mm. When we undertake the process of overhauling an engine, it includes disassembling the engine to facilitate thorough servicing. This comprehensive servicing encompasses essential tasks such as cleaning, thorough inspection, and the subsequent reassembly of the engine components. The inspection of engine components needs measuring instruments with more accuracy than 0.5 mm, and such types of measuring instruments are called precision measuring instruments. Within the industry, a range of precision measuring instruments are utilized to ensure accuracy and precision in various processes. A few of them are shown here for reference. Micrometer is one of the important precision measuring instruments which has a measuring accuracy of 0.01 mm. And micrometers are available in various types based on their purpose. They are outside, inside and depth micrometers. Now, I am going to explain how to measure the outside diameter of the engine components like cam height, camshaft and crankshaft journal diameter, valve stem diameter, piston and piston pin diameter with outside micrometer.
At the end of this demonstration, you will be able to select the correct range of outside micrometer. Hold the micrometer for measurement. Set the micrometer on work. Read the measurement on outside micrometer. Tools required: surface plate, V blocks. Instruments required: outside micrometers in different range. Materials required: camshaft, crankshaft, piston pin, lubricating oil, bunny and waste. Outside micrometer is a precision measuring instrument which is used to measure the outer diameter of the components with an accuracy of 0.01 mm. Based on the measuring systems, the micrometer is classified as metric micrometer, British micrometer. Mostly metric micrometers are used in our country for measuring purposes. Based on the range, the outside micrometers are classified into 0 to 25 mm, 25 to 50 mm, 50 to 75 mm, 75 to 100 mm, 100 to 125 mm, and 125 to 150 mm. Let us get to know the parts of the micrometer. They are as follows: frame, anvil, spindle, measuring faces, lock, sleeve with graduations, thimble, ratchet stop. Read the values at the point of reading. Usually, a test piece is given separately to fix zero error except for 0 to 25 mm micrometers. In this module, we are going to learn to measure the diameter of the components with a metric micrometer. In metric micrometers, the main scale has an accuracy of 1.00 mm in the barrel and it is marked above the index line. The main scale is again divided into two and marked below the index line. Its value is 0.5 mm. Its thimble has 50 divisions. The size and accuracy of the micrometer is engraved in the frame. The micrometer may be held either in one hand or by both the hands. While holding the micrometer on your right hand, keeping the graduations on the main scale towards you. Support the frame on the lower center of your palm. Use your little finger or third finger to hold the frame in the palm. Place the middle finger behind the frame to support it. Keep the first finger and thumb free to adjust the knurled thimble. Suppose you are going to hold by both the hands, then support the frame between the fingers and the thumb of your left hand. Use the thumb and finger of your right hand to adjust the thimble. Before going for any measurement, check the size of the component to be measured with an outside caliper. Then select the correct range of micrometers. Now check any error in the micrometer. First, release the lock. For 0 to 25 mm micrometer, rotate the knurled surface of the thimble till both the measuring surfaces are very near and then start rotating the thimble by ratchet. Rotate the object until the distinctive ratchet sound is heard and cease rotation upon hearing the characteristic noise associated with the ratchet mechanism. For other range of micrometers, use the correct size of test piece in between the measuring surfaces for zero error. Now calculate the error if any. Suppose the zero of the thimble perfectly matches with the datum line of the main scale, then note down the error is 0 or no zero error. If the zero of the thimble does not match with the datum line, and if it is below the datum line, then the error is called positive zero error. Note down how many divisions are below the datum line. For example, in this image it is 2 divisions, that is plus 0.02 mm positive zero error. Similarly, if the zero line of the thimble scale is above the datum line, then the error is called negative zero error. Note down the divisions and multiply the total divisions deviated with the least count, that is 0.01 mm, you will get negative zero error. For example, as in this image, it is minus 0.04 mm. Method of reading the micrometer. Look at the reading which has been taken from the workpiece. Read on the barrel scale 1 mm increments, the number of whole millimeters that are completely visible from the bevel edge of the thimble. Example: 7.00 millimeter. Add any half millimeters that are completely visible from the bevel edge of the thimble. If visible, then count 0.5 millimeter or 0 if not visible. Example: 0.00 millimeter. Add the thimble reading to the main scale reading which has already been taken. Example: 14 divisions of 14 into 0.01 millimeter is equal to 0.14 millimeter. Total reading equal to 7.00 plus 0.00 plus 0.14 equal to 7.14 millimeter. Now, I am going to demonstrate how to measure the cam height and journal diameter of the camshaft with a metric outside micrometer. Before measuring the camshaft, clean the surface plate and apply a layer of oil. Place the correct size of V-blocks properly on the surface plate. Select the camshaft to be measured and clean it thoroughly. Place the camshaft on the V-blocks. Select the correct size of the metric micrometer. Say for example, the approximate size of the cam is 40.00 millimeter. Then select a 25 to 50 millimeter micrometer. Check any error in the micrometer and note down the value. Following which, release the lock. Then rotate the knurled surface of the thimble in anti-clockwise direction slightly above the approximate measured value. Now place the measuring faces of the anvil and spindle on the cam to be measured and rotate the thimble with the ratchet in clockwise, that is screwing towards the frame. After hearing the ratchet sound, stop rotation and lock it. Try to move the micrometer on the measuring surfaces of the cam and feel a small friction on the measuring faces of the micrometer. Then, take out the micrometer from the cam and note down the values in the tabular column shown below. In the similar manner, measure the camshaft journal and enter the values in the tabular column. Next, clean the crankshaft to be measured. Place the crankshaft on the surface plate with the support of V-blocks. Measure the crankshaft journal and record the values in the tabular column. Clean the valve to be measured. Hold the valve in one hand and keep the micrometer with the other hand. Measure the stem diameter in 3 different places to check for any taper and record the values. Check for any scuffing. Clean the given piston to be measured. Place the piston on the surface plate. Measure the piston diameter in its skirt as shown following the manufacturer's specifications and record the values. Moving on, clean the piston pin and hold in your right hand. Keep the micrometer with the left hand, measure and record the values.
Let us have a recap of what we have learned in this module. We have learned to select the correct range of outside micrometer. Hold the micrometer for measurement. Set the micrometer on work. Read the measurement on outside micrometer. Thus, we have learnt how to measure cam height, camshaft journal dia, crankshaft journal dia, valve stem dia, piston diameter and piston pin dia with outside micrometers. Hope you are clear on this. Do this exercise with the help of your instructor. Thank you. Carry out measuring practice on the height of the rotor of an oil pump from the surface of the housing or any other auto component measurement with a depth micrometer. Hi, my name is Charumati. Hope you are all excited for today's session. Automobile service industry involves general maintenance as per the manufacturer's schedule. troubleshooting the problems and rectification of faults by dismantling the particular assembly, inspection, replacement or repairing of problematic components and assembling. The inspection mainly includes measurement. Many inspection methods require linear measurements like length, diameter and depth measurements. The depth measurement can be carried out with precision measuring instruments like depth micrometers. Now we are going to learn how to carry out the depth measurements with a depth micrometer.
At the end of this demonstration, you will be able to select the correct range of depth micrometer, setting the micrometer with error calculation, set the micrometer on work, read the measurement on the micrometer, tools and instruments required, surface plate, depth micrometer with extension rods, gauge block, materials required, lubricating oil, Bunnier waste. Depth micrometer is a precision measuring instrument which is used to measure the depth of any components. Based on the graduations, the depth micrometer is classified as British micrometer, metric micrometer. Nowadays, the automotive service industry uses metric measurements only. So, now I'm going to explain how to take readings with metric micrometer. Before going for measurement, we should know the parts and its functions. Depth micrometer consists of the following parts: stock, lock, barrel or sleeve, thimble, cap, extension rods. Stock has measuring faces and placed the surfaces to be measured. Lock is used to lock after taking the measurements, and then only we can remove the instrument. So, the reading taken cannot be changed. Barrel has an index line in its center and graduations are marked on the sides of the index line. Thimble has graduations around it and a graduated sleeve on its bevel edge from where we can measure the readings. Different size extension rods are provided with the depth micrometer, and we can select any one based on the depth of the part to be measured. The extension rod can be inserted inside the thimble and the sleeve by removing the cap. The extension rod has a collar head which helps the rod to be held firmly. Measuring systems. Barrel or sleeve has an index line. Main scale is marked above the index line and has an accuracy of 1 mm. The main scale is again divided into two and marked below the index line. The thimble is divided into 50 equal parts, and after multiplying with the least count, one division has 0.01 mm, which is the accuracy of the depth micrometer. Before taking for any measurements, measure the depth to be measured approximately with steel rule or other usual measuring instruments. Then select the proper extension rod. For example, if the measuring value is say 15.00 mm, then select 0 to 25 mm extension rod. If the value will be 45.00 mm, then select a 25 to 50 mm extension rod. Remove the cap from the depth micrometer. Insert the extension rod till the collar touches it. Retighten the cap. Now check for any error in the micrometer. For example, if you want to check the error in the 0 to 25 mm depth micrometer, then place the measuring surfaces of the micrometer firmly on the surface plate. For other micrometers, use a gauge block for zero error checking. Tighten the thimble by rotating it in a clockwise direction. Stop rotation when the tip of the rod touches the surface plate. This can be only observed by feel. Now observe the zeroth line of the thimble and index line where it coincides. If both the lines coincide, then there is no error or zero error. If the zero line of the thimble is below the index line, then it is a positive error. Count the divisions deviated from the index line. For example, two divisions are deviated, then the error is plus 0.02 mm. If the zero line of the thimble is above the index line, then it is a negative error. Count the divisions deviated from the index line. For example, one division is deviated, then the error is minus 0.01 mm. Now, we are going to measure the depth of a rotor of an oil pump with a depth micrometer. Take a rotor type oil pump. Clean it thoroughly. Remove the cover from the oil pump. Take out the rotors and clean it with a clean cloth. Place the rotors again in the oil pump body. Select a micrometer with the correct size extension rod. Place the measuring faces of the stock firmly on the top surface of the rotor body. Unlock the thimble. Screw the thimble till the tip of the extension rod touches the bottom of the body where the rotor sits. Now tighten the lock. Remove the micrometer from the oil pump. Take the readings. Note down the reading of the main scale, which is nearer to the bevel edge of the thimble. Note any subscale reading can be visible after the main scale value. If so, note down 0.5 mm or mention 0. Note down the thimble value which coincides with the index line. Now tabulate all the readings and calculate. You will get the original reading.
Thus, we have learnt to measure the height of the rotor of an oil pump from the surface of the housing or any other auto component measurement with a depth micrometer. Hope you are clear on this. Do this exercise with the help of your instructor. Thank you.
Namaskar and a very good morning. I am K.K. Mishra from Ministry of Power, Government of India. And I am here to discuss and talk about the various initiatives taken by Government of India, Ministry of Power regarding digital initiatives. This is a creation of an ecosystem which enables consumer not only to facilitate the various